questions together.
In section 2?
And 12, yeah. And then, or at least, talk through part 2 before we try and do the quiz, since obviously we're all a little lost.
Yeah. Yep, that was my problem. I only had one side of my curve highlighted. All right, that makes sense. I can take number 1. It says, what does it mean to have matched pair data? And I said, it means you take 2 observations of the same measurement on each subject. So I might actually use this method at work, where I'm trying to figure out more efficient ways to do things, and sometimes it goes horribly wrong. Like if I switch something up, like a process of dealing with hazmat packages, occasionally whenever I change that, it either yields a good result and it's faster, or we start making mistakes and it makes it much longer in the long run.
So this is kind of real world for you. You could actually use some of this.
Yeah. I think the idea is cool, but I haven't gotten the mechanics of it yet. Because I actually could use it. So does anybody disagree, or do we concur on number 1?
No, but I did end up copying what he wrote down just so I could memorize it for when we have the next unit test.
Yeah. Then number 2, I had a question about number 2.
I'm not sure.
Not sure either.
Oh, about number 2?
Yeah.
I wrote down what I thought was the answer because it says differences, plural, and then in the answer sheet it just says open-ended.
Open-ended, yeah. Like what does that mean? I should have Googled it. I'll go see if it gives me something intelligent.
What are the differences in the hypothesis tests? So the hypothesis test is just inputting, it's getting the p-value, and we use the probability applet to do that. So if we always use open-ended tests for matched pair data, why do we only use one-sided tests for one sample data? That's my question.
Well, with the one sample t, it can be any of the 3. It can be greater than, less than, or not equal to. So it can be one-tailed or two-tailed. What I didn't understand is why the matched pairs, the way he was talking, it sounded like the matched tails have to be
open-ended,
two-tailed, which I guess counts as two-tailed always. I didn't understand why.
Yeah, I don't get that either. Let me Google it. Why are matched pair T's? What is it? Always open-ended. Ooh, that's interesting. It's not related, but it's interesting.
Okay.
Apparently, the DFs are not always a whole number. The I can't remember what DF stands for, but
The degrees of freedom?
yeah, the degrees of freedom apparently are not always a whole number. But I don't see anything that explains why it's open-ended. So it's a pair of data.
But essentially, it's the same as a one sample t-test, because with the matched pairs, you're only ever looking at the differences.
One set of data, yeah.
Yes. So, but I somehow, because it's a matched pair, it can only be not equal to. Whereas with the other one sample t-test, you can have less than, greater than, or not equal to. So one-tailed or two-tailed. So maybe that's the difference.
I think you're right. I think it's just the nature of the data. The data is different, even though, like, oh, think about it. The data could take longer to perform the business process, or it could take less time. So you have to leave it open-ended because you're not looking for a specific value. You're just seeing if it's lower or higher. It's starting to make a little bit of sense because the values in the difference column can be negative or positive, which would mean they were lower or higher. Likelihood is you're not going to just have, oh, but sometimes all the numbers will be lower.
Yes.
So what do you do with the upper tail in that instance?
I have no idea, but maybe we're going to talk about that later. I can
Yeah.
something.
Okay.
I'm trying to type in a little bit of what I said. Sorry, just a sec. I'm going to go back and talk to my dad about this. If he and I come up with anything simple and brilliant, I'll share. All right,
Sounds
so
good.
part 2, matched paired T procedure. A manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. He measures the amount of time in minutes 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different. I underlined that for myself, saying it's a two-tailed, and uses the level of significance of alpha equals 0.05. So 3A, what is the research question? I put down, will the new procedure reduce the process time to complete 100 units of product? Question mark.
Yeah, I worded it just a little differently. It says, do his efforts to reduce assembly line time work? But in reality, he's just trying to see if it makes it better or worse. I assumed that he was just trying to reduce the time, but apparently
Reduce or increase. No, that doesn't hurt. Will the new procedure reduce or increase the process time to complete 100 units of product?
Because I've learned that sometimes your little tests do make your day longer. It doesn't always yield a good result. And it makes other people hate you.
I can believe that.
I'll not hate, just be annoyed with.
Okay. And then state the null and alternative, hypothesis. So H sub O colon mu sub D equals 0. Or the null hypothesis is the mean of the differences equals 0. H sub A colon mu sub D does not equal 0. And when I first went through, I made it less than 0, thinking he wants to find out if he can reduce the time, but these are always not equal to. So the alternative hypothesis is the mean of the differences does not equal 0.
Mm-hmm.
And Eric, do you want to start 4?
Yeah. So that's another difference between the match
Pairs?
Yeah, match pairs in the one test. Because they started using 0 for null and alternative hypothesis.
The null hypothesis is always 0. Yeah. Oh, okay. And then the alternative has to always be does not equal 0.
Mm-hmm.
Yeah.
Interesting.
And Trin had a question about what happens when we get when we get negative results. And there was a video that the teacher was explaining this, and I want to share my screen really quick so you guys can read it.
Yeah.
Okay.
Sure.
Gonna go. So, can you guys see?
Yeah.
Okay, so here the results for this exercise were negative.
All negative.
Yeah, and he says since 0 is not in our confidence interval, there does appear to be a mean difference in post-study versus pre-study.
Mm-hmm.
So basically, if our result is negative, and 0 is not between those two results, then there is a difference.
Meaning the women did lose weight.
Yeah, and if 0 is between those results, there wasn't a difference. There was
Not enough of a difference.
Yeah.
Oh, okay.
Okay.
Okay, thanks. So
What's that?
if all the results are negative, then
the p-value is definitely less than the alpha, what do they call it? Level of significance.
okay.
And if the p-value is less than the level of significance, you reject the null.
Correct. I did get that right on the preparation assignment.
Me too. Okay.
Which one are we reading now?
We were doing number 4, collect the data.
Okay, I can do that one.
Okay.
All right. Collect the data. So I said he recorded the times from 9 of his employees, and then but we don't know if this was a simple random sample or not. That was just a little note that I made to myself. But he recorded the times, changed the procedure, and then recorded the times again of how long it took them to make 100 products.
Yeah, I put the researchers collected times from the same 9 workers before and after the process change was implemented, creating 100 units of product each time. All right, Anetic, do you want to describe the data?
Yeah, number 5, describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. So I basically just copy this from the answer skits. D bar equals positive or negative 1.0656. S difference equals 2.596, n equals 9.
I had the same. Sorry. I got everything except for the histogram right. My histogram showed it was right skewed, but when I looked at the answer, it was left skewed.
Yeah, what my confusion was, why could it be plus or minus when basically in the book it's telling us that D bar equals x sub 2 minus x sub 1, meaning post minus pre. So if you always do post minus pre, you're going to get, for the most part, a negative number. Whereas if we were doing it the other way around, it would be positive 1.053. So the plus or minus I didn't get, because my numbers were right. I got negative 1.056 for the D bar, the difference in the sample mean. Although, yeah, one of my, you're right. So like the pre-assembly changes histogram, it was, now I'm going to get it backwards. Went that way. Whereas in my differences, it went that way. I have to look at which way is which again. Yeah, so I'm not understanding why it could be plus or minus for the D bar, but anyway. Okay, make inferences. Number 6. A, what type of hypothesis test is appropriate? A two-tailed paired sample t-test is the appropriate hypothesis test to perform. What are the requirements for this test? The sample mean of the differences must come from a normal distribution, and we assume a simple random sample. Is there a third, or is it just those two?
Just those two.
Okay. So compute the differences between the two times and determine if the requirements are met for this test. Explain your answer. I said since n is less than 30, we need to do a QQ plot test to see if the distribution is normal. And then I copy and pasted my QQ plot, from the whatever. And then his answer was interesting. Because, yeah, when I did the QQ plot, I was like, that didn't look all that normal. And then going back into his answers, it doesn't look all that normal, but we're going to assume that it is because we only have 9
7
points.
or 9.
I was like, okay. Yeah, D, continue with the test regardless of what you found in part C. Compute the test statistic. T equals...
1.22.
Yeah, negative 1.220. So
I actually got positive. Oh, let me go back. Let me see. Never mind. I erased. I didn't save all that data.
as long yeah. That's because your original T was positive. Remember, if you do pre minus post, you're going to get a positive answer on this one anyway. If you do post minus pre, you're going to get a negative answer. And I just stayed post minus pre because it says in the book d bar equals x sub 2 minus x sub 1. X sub 2 meaning the second set of data, x sub 1 meaning the first set of data.
Yeah, I guess depending. I actually haven't been working with that equation. Maybe that's a problem. I've just been inputting the data into the spreadsheet and then
but so variable 1 in the paired sample t test is supposed to be post, and then variable 2 is supposed to be pre, and then you'll get, at least for this one, all negative answers because they all lost weight, if I'm thinking the right one. Which is counterintuitive. You would think variable 1 equals pre, variable 2 equals post, but no. At least not according to the way I was reading the book.
Okay. I'll have to review that because I think I looked at the first part of the textbook on Monday. I think I remember it talking about that, and then I did the second part yesterday. So it's like I get to review.
It's under so computing new variables in Excel. It says difference equals post minus pre. And then somewhere else it called it x sub 2 minus x sub 1.
Yeah, I remember seeing the equation.
So again, that was why
I input the data.
That was why I was confused when he was saying it could be positive or negative. And I was like, okay, if it's post minus pre, at least in the one example in the book, and then the one that we were doing for this, it was all negative. So I don't know. Yeah. All right, Trent, keep going. Sorry.
With the degree of freedom, I got 8. And then the p-value, I originally got 0.1286, which was still greater than, but that was because I only shaded in one side, one tail, the low side. But if I do both,
on the quantitative inference procedures Excel sheet, if you've filled everything in, it'll actually give you the p-value. And I think I had the numbers that you got the first time because I had it, the type of test is less than rather than not equal to. Once I fixed the not equal to, it gave me the p-value on the Excel sheet.
Yeah. So it knew if there were a bell curve on that Excel sheet, it would be as if you switched it from one tail to two tail.
Mm-hmm.
Okay. That makes sense. And I chose not to fail to reject the null hypothesis because even with only one tail shaded, it is still greater than 0.05 or 0.05. And so we would fail to reject the null hypothesis.
Yes.
Whose turn is it?
I think we keep skipping over anetic.
I think so.
Do you want to take a Germanetic?
That's fine. So which one now?
We're F.
Yeah.
H.
Yeah, H.
Present your conclusions in the form of an English statement. We have sufficient evidence to say that the time to make 100 products is any different after the implementation of the new assembly procedure. So,
Did you say sufficient or insufficient?
insufficient.
Yeah.
Yeah.
That's
what
what
I've got.
Then I is oh, here we go. Margin of error again. I put down the equation that I put in Excel, but not the answer that I got from Excel. Let me paste that back into. So for the equation, for the margin of error, I had 1.96 times 2.56 over 3, which is the square root of 9. What did y'all put for that question?
I put the confidence interval. That the lower level is negative 3.051, and then the upper level was 0.940. But maybe I was wrong. I don't know if I checked that or not. No, it says that's what the confidence level. Although it looks like it depends on whether you did the pre minus post. Pre minus post, it's negative 0.9 da 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 da. Or when I did the post minus pre, there's my numbers: negative 3.0508, comma 0.9397.
Okay, I actually failed to do this one, so I'm going to have to input that information real quick.
Again, that shows up on the paired sample t-test for means. So like the bottom one that says differences, first it's the t, and then it gives you the degrees of freedom, and then the p-value, and then just to the right of that, confidence interval.
Yeah, I didn't write that down whenever I had it pulled up.
If you did it the positive way, then it's that first set of numbers on the answer key, negative 0.9397, comma, positive 3.0508, which is basically just my numbers switched and then the negative and the positive switched. Interesting.
So it can be either or.
So far, that's what it looks like. But then when I read the book says no. So I'm when you talk to the TA, would you ask, please?
Yeah, let me write that down. So referring to 6I.
Well, it works for both. Pretty much any of the ones where he says, like in 5, d bar equals plus or minus 1.056, depending on the difference taken. And then, yeah, here at 6I, because if you're following the book, it says difference equals post minus pre. That's the order it's telling us to do it in, and that would mean that it would make it negative and the other set of data that I got. So Why? Yeah.
So,
Or
the
does it not
question
really
is,
matter?
so is either pre minus post, is either acceptable pre or
Post.
post minus pre?
Basically, I have it in my head as x2 or x sub 2 minus x sub 1. Because that was also, it was either in the book or in one of the videos.
So it'd be post minus pre.
Exactly.
Okay. All right, I will ask.
And how do we get the margin of error using the Excel applet?
It looks like the margin of error is the confidence level. The lower level versus the upper level. Now, admittedly, you need to know, like, if they really wanted, you know, is it -3 or +3 or whatever, you could take the S, the standard deviation, and then, you know, subtract the lower level and add the upper level, and that gives you that, whatever that number is. But I just put in the confidence level and went and checked, and he said we would create a 95% confidence interval, not confidence level, confidence interval using the t-distribution and then those numbers. So the lower level and the upper level, and that's the margin of error.
Okay.
They're relatively interchangeable.
Okay. Well, I have that question written down. I will ask the TA when I'm able to meet with. Is it a him or a her?
The one I got was a him.
Okay.
Although honestly, I found him less than helpful. Maybe he will be better for you. Okay, whose turn is it for 7?
I think it's my turn. Actually, no, I think it's your turn.
My turn, okay.
Yeah.
In a short paragraph, describe the action you feel should be taken based on the statistical results above. I said there was no statistical gain for implementing the new assembly procedure, therefore try a different plan.
Yeah. I had it in one sentence. I said I would try another strategy to reduce assembly line time.
Essentially the same thing.
Yeah. But I wrote that. All right.
Do we want to try the quiz?
Let's do it.
All right.
Let's do it. Too bad Edward's not here.
Yeah, seriously.
He's smart.
He's a lot more comfortable with the math.
Yeah.
Okay, I'm downloading the chapter XLSs it wants us to.
I think it's interesting that one thing I find interesting is how we each get different things. Like we're all strong at different principles.
Yes. Well, and we're catching different portions from, say, like the reading versus the. All right. So I've downloaded everything it says for us to download. How about you guys? You ready?
Not quite.
Enemy of the Republic took my pencil. Thank you.
All right.
All right.
A way to set up my download folder. Actually, I guess you wouldn't know, you're a Mac user. Enetic, do you use Mac or Windows?
Use Windows.
Is there a way to set up downloads to go straight to my desktop?
Yeah, pretty sure there is a way.
Okay, I'll have to Google that.
Shortcut.
Yeah, that sure would be nice, because I wind up, every time I download something, I have to open it in the folder where it just sends it straight to my hard drive. Then I pull it out of the hard. Well, I guess it's on the hard drive anyway, but it sends it to like a general folder, and I have to pull it out every time I download it so I can find it a little easier. Okay, but I've got them downloaded now. So I'll start with the reading. It says, suppose we have a set of paired data and let D equal X after minus X before.
So X sub 2 minus X sub 1. Okay.
Mm-hmm. The null hypothesis is mu D equals 0, and the alternative hypothesis is mu D is not equal to 0. And the population standard deviation is not known. Jordan collects a sample of size of 9 and computes D bar equals 2.2 and SD equals 3.3. Is the value of the test statistic. So they're looking for T, the T value. Okay.
9 equals 9. D bar is 2.2. And then standard deviation of D is 3.3. So we start with T equals D bar minus 0 over S sub D over the square root of N.
Okay.
So 2.2 minus 0 all over 3.3 divided by the square root of N, which is 9. 9 needed. Excel sheet open. Not right now. I'm doing a quiz. I'll have to wait.
Exactly.
Yes, I got 2 even. And it's up at the beginning. It says, do not round until your calculations
T equals 2 then.
Yeah, so T equals 2. Did you get that, Enetic? Are we good?
I'm still working on it. So we're supposed to use 2.2 minus 0.
Yes.
All right.
All over 3.3 divided by the square root of 9.
Okay, yeah.
Dos.
Okay. Who wants to read question 4?
I'll read it. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
Wouldn't 0.0403 be the probability? Because if we put the t value into the probability applet, that should give us the problem.
Okay, well, first put in the degrees of freedom. So n minus 1 is 8. Yeah, it's asking for p instead of t. All right, I'm confused. Probability of obtaining a test statistic greater than Jordan's test statistic of 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
I think you're on the right track. Because P is just the area at the top of the probability applet. So if P is the probability, I think if we just put the t-score into the probability applet with the degree of freedom, that should give us P.
So 0.04, what was it? It says t equals negative 2.444 or positive t.444.
So it says the probability of obtaining it.
Oh, wait, so the test statistic is 0.0403. We should be putting that at the bottom.
Yeah, right.
So the probability, the p-value is 0.9688.
So you put 0.0403 into the t-score
Yes.
section of the probability applet?
Yeah, 0.0403, although it got rid of the 3.
And we're supposed to shade what side?
It's both tails are shaded because the alternative hypothesis is not equal to. So it's two-tailed.
She has to share
Share what?
her gummy frogs.
She has gummy frogs? Where did she get gummy frogs?
I don't know.
Did our new... Okay.
No, they didn't come.
Hi, Emma. Please share gummy frogs with John. That doesn't mean you get half the bag, which does need to share some. Close the door, please. So 0.9688.
But the question says, what's the probability of obtaining a test statistic greater than Jordan's statistic?
Okay.
Huh.
So
Well, I don't get why their test statistic, if we just worked out the t value in number 3, because normally we would just input 2 or the t value into the probability applet, and that would give us the probability. I don't know, see why they're throwing 0.04 or 0.03 in there.
It is they're calling it the test. So a probability of obtaining a test statistic, so that is a t, greater than Jordan's test statistic, that's a t, so a t of 0.0403. So,
all right, so if it's the part, if that's the part of the test statistics that's greater than, then we would just shade in the top.
yes. And if it's greater than, we could put 0.0404. So it's greater than 403. And that gives me a probability of 0.4844.
Yeah.
So 0.484, I'm assuming we want 3. There we go, round to 3 decimals.
Mm-hmm.
Does that make sense, Anetic?
Yes.
0.484.
Zero point four. That's just weird. They've never done that before.
Probably trying to make us think, I guess. All right, so we're using Chapter 12, Data A1 for the next 6 questions. So we want the paired sample t-test for means in Excel open, even though it says SPSS, we obviously are allowed to use Excel. Everybody got that open already?
Hmm.
So be sure that the test does group 1 minus group 2. Group 1 minus group 2. So the null hypothesis is H sub O colon mu sub D equals 0. Or the null hypothesis is the mu of the differences equals 0. And the alternative hypothesis is H sub A colon mu sub D does not equal 0. Again, still two-tailed. And our level of significance has changed. Alpha equals 0.10. So that's a 90% confidence level. So let's get our stuff and plug it into the thing. So group 1 goes into variable 1. Oh, actually, we need to do the differences first, don't we?
My files disappeared.
Oh, no.
It says they're on my desktop, but I don't see them. Oh.
Yeah, group 1 minus group 2.
Okay, well, third time's a charm. Hmm.
Remember to paste values when you're moving your information.
Yeah, I was confused at first and it just showed an error. What am I doing wrong? All right, uno.
Still not equal to, and then we got to change the confidence level to 0.90. Null hypothesis is 0. And do we have an n? N is how many? I need to count. N is 20.
Yeah, it's 20.
All right. So what is the test statistic? My Excel spreadsheet spit out positive 0.407.
Yep, I got 0.407. What did you say you got again?
0.407.
Okay, same thing.
Yep, same thing.
Cool.
And Edic, did you get the same thing?
What's the confidence level we have to use?
Confidence level is 0.90
See.
because alpha is 0.10 or 10, excuse me.
All right.
I get
that is-
till 0.407.
Yep. Good.
Okay.
We're all the same. So p-value equals 0.689 if we round to 3 decimal places. Yes?
Yeah.
All right. What is the correct decision based on this evidence? P-value is 0.689 and alpha is 0.10, so p-value is greater than alpha.
Yeah, alpha was 0.10,
Yes,
0.1.
0.10.
Yep, so we failed to reject. It's greater than.
Failed to reject the null. All right, suppose your alternative hypothesis is instead,
Can I make ramen?
no, we're having dinner as soon as I'm finished. And I brought home Jimmy John's.
Is ramen lunch?
John, you're interrupting. Alternative hypothesis is the mu of d is greater than 0 rather than not equal to 0. What is the correct decision based on this evidence? Okay, so we changed the type of test on our page from not equal to greater than. And that changes our p-value to 0.344. That is still greater than 0.1. So we still reject the null. So we have insufficient evidence that the mean of the differences is greater than 0. Is that right?
Correct, because the null hypothesis is that it is equal to 0. So we would keep that.
I'm putting it back to not equal to just in case we have to do something again.
So what is the right answer?
Good
The
idea.
first one?
We have insufficient evidence
It's not equal to 0.
Yeah, no, greater than 0. because we've changed the alternative hypothesis.
Oh, good. Some easy ones. Or an easy one.
Okay, so we need to go back and clear contents and everything, right? Before we
Yeah.
start. Edit PDR contents. Get rid of my N. Clear contents. I'm sorry, I talk too much sometimes. Ignore me if I'm. You can tell me to shut up. So now we're on database D.
Hallelujah.
Okay, and again, in bold, be sure that the test does group 1 minus group 2.
So that would be pre minus post.
I think they're just calling it 1 minus 2. I would hope that it's post minus pre, but whatever. They're telling us 1 minus 2. Okay. So the null hypothesis is H sub O colon mu sub D equals 0. And the alternative hypothesis is H sub A colon mu sub D does not equal 0. So we need to make sure we're still not equal to on our paired sample t-test. And our alpha, our level of significance, is 0.01. So that means our confidence level is 99. So we want to put 0.99 in there.
This is a very inclusive test.
Yeah, my problem is they make it, I see it feels like the group quizzes are significantly easier than the homework quizzes. Like I'll feel like I'm doing okay. I have at least a decent grasp on the information, and then I get to the homework quiz and I'm like, okay, maybe I don't.
No.
All right, group 1 minus group 2. I know my differences. Group 1 minus group 2. 1 minus 2. Now I can do the copy the whole thing, get the dark plus, and it can do it for me.
So group 1 minus group 2. So just like it's set up in the Excel in the data sheet.
And then I'm saying this out loud for myself, sorry guys, but remember to paste the values. Okay, so N is 22, right?
Mm-hmm. So which is greater, N or DF? I think
Degrees of freedom is always N minus 1.
so. N is always greater.
Yes. So 9 is N. And Edic, you with us, or are we moving too fast?
No, I'm here.
Okay.
Ready for the next one. It's what's the p-value? I got 0.001215.
35.
Hopefully,
I've got 0.0012 and then
yeah,
everything else.
that's what I got.
So we just need 0.001.
Y'all got 0.001.
Yes.
I got 0.004 somehow.
Do you still have type of test not equal to, or is it still when we changed it?
Correct. I have it to not equal to. I have the
All right.
confidence level at 0.99.
N equals 22.
Correct.
Okay, so my differences are 39, 22, 25, 11, 33, 9, 19, 21, 3, 1, 2, 15, 10, 1, 17, negative 22, 15, negative 11, 8, negative 10, 25, and 30.
I have the same.
Right.
What is going on? What is different? I get rid of it.
And you're using database
Okay.
G.
All right. I see what's going on. Did y'all put anything in for the mean or standard deviation?
No.
Nope.
Okay. I just deleted those two columns and I got 0.001. So I think that was it.
Okay.
Now,
You just put stuff in from when I clear contents, I clear everything.
yeah, I just forgot to clear those two cells.
Yeah.
So do we
that-
ever use that, or do we always leave mean and standard deviation blank?
I filled them in before on the other sheet, but lately I haven't been filling it in only because I'll forget to empty it.
Clear it.
Because it gives us, on that bottom, it gives us the mean of the differences, the standard deviation of it gives us it there on that that middle chart where variable 1, variable 2 differences.
Yeah, I see that now.
I haven't been filling it in because it's there in another spot. Now,
Yeah,
maybe later on we'll have to, maybe later on we'll have to fill it in, but for now I've been leaving it alone just because it's one more thing to remember to empty.
Yeah. Sounds good. Well, it's clear, and I got the same answer. So what decision do you make? Ooh, that's a tough one. It is,
0.001
so it's less.
is less
It's
than,
less, so we reject the null hypothesis.
yes. And I have to go back and, which means the mu of the differences does not equal 0. Okay. I'm
So
not.
this,
What would that? Okay, I want to talk through this for just a sec, just because we're all together. So if we were finishing this hypothesis test, what would that mean about this data? We reject the null, so the mu of the differences does not equal 0. So this is about what? It's not even telling us what this data is about.
no.
Nosocomial infections. So I guess we don't know whether this is about, the stuff is working or the stuff is not, the medicine's working or the medicine's not working, or so we just don't know. All right. Sorry.
No, you're good. Number 12. So you decide to try another alternative hypothesis. This time you use mu d is greater than 0.
So we change the type of test
To greater than. that makes it much smaller.
And you keep the same level of significance. Did the p-value increase or decrease?
It decreased.
Yeah, a lot. So what decision do you make?
Reject the null. So based on your response from the previous question, what conclusion do you make? So, we have sufficient evidence that there's a mean difference between the two groups. So if that means that a change needs to be made, meaning that there is a significant chance. The low p-score means that there was a very small chance that we could obtain those same results by chance.
Random chance, yes.
So yeah, that means that there's a big enough difference that it's very unlikely for those values to occur randomly. So we have sufficient evidence that there's a mean difference between the two groups. So I would say C.
Yes.
Huh. Yeah, that is interesting. The p-value depends on the alternative hypothesis. Seems like greater than would.
For what?
I think the next one is either C or D.
So I'm writing stuff for myself, just a sec. Okay, as we've seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Well, let's play with it. Greater than is small. Not equal to is significantly bigger. Less than is a lot bigger.
Yeah.
So it would be greater
Greater
than.
than. So mu sub d is greater than 0, gives us the smallest p-value. Okay, so determine the 95% confidence interval for the mean difference between the two groups. So we change confidence level to 0.95.
And do you think we change the type of test back to not equal to?
I would suggest that, yes. But I'm not sure.
Okay.
What is the point estimate for this 95% confidence interval?
The point estimate, meaning I think that's the t-score.
That's the t-score. I have 3.737.
I have the same.
Got the same.
All right. What is the margin of error for this confidence interval?
So I think that would be at 95%. That is 1.645.
Where
Or
are
is
you,
that?
where are you getting that?
So I believe the equation is the t-score for 95%, which would be you know how we've been working with like 99% confidence intervals and 95, and it's roughly the same. It's like 1.645 is one of them, and then 1.96 is another. I think 1.96 is for 95%.
I thought it would be the mean minus whatever gives us the bottom confidence level, the mean of the differences, plus whatever gives us the top confidence, whatever the difference is between that top confidence level and or confidence interval and the bottom confidence interval versus the mean of the differences.
That may be it. I probably missed that.
I can't remember what the, I don't remember what the formula is to get that, but I would think that it would be let's see if it's the same. Mean of the differences is 11.955. Subtract 18.607. Enter equal sign. Gives me negative 6.51. Okay, so 11.955. I stick that backwards in there. Oh, whatever.
Hey, Trent. I made a nugget.
You might be on camera, Ethan.
I should have done that. I did that backwards. 18.605 minus 11.955 gives me that.
I made my
And then 7.955 minus 0.203. I'm thinking that, fine. Keep getting my sign. Yeah, so the margin of error is plus or minus 6.652.
So I'm looking for that equation in chapter 12. I'm not seeing it.
Maybe it's.
Was it in chapter 11?
Yeah, maybe it's in 11. I just know it's the mean. The mean plus the margin of error gives you the upper confidence interval. The mean minus the margin of error gives you the lower confidence interval. So I knew I could work backwards to get the number. I just don't remember what the
What the formula
yeah,
is?
what the formula is.
Okay, well that's pretty cool. I wouldn't have thought to do that. Let me see if I can find it.
Well, remember when we were doing z-scores, that's, it was the, that one like the, actually maybe it's just the bottom half, the standard deviation divided by the square root of n. Because on the z-score, it was just that bottom part there, that was the margin of error. Or no, that's not it.
It was z-score times sigma over square root of n.
Yeah.
Yeah. And I think the only thing what I thought it changed was just
So maybe
t T instead of Z.
Yeah. So now it's the S sub D divided by the square root of N. I wonder if that's the I wonder, let's see if that gives us the 6.652. So standard deviation of the differences is 15.003 divided by a square root of N is 9. So get to something here. Root of 9. Nope, I got a different number.
Did you multiply it by the probability at 0.95? There's the T score.
Hmm?
So in the Z score, the margin of error for Z score includes the I can't remember what the number is called, but basically it's tied to the
It's called the critical value.
confidence level. Yeah, the critical value. It's like 1.96 and 1.645 depending on the confidence level.
It's got to be a little bit more complicated for the T because we have these degrees of freedom that affect. There's got to be something.
Maybe it's the same thing. Maybe we just use the T probability applet. And as long as we have the degrees of freedom right, maybe it'll give us the right
Yeah,
value.
good idea.
Okay, what do you mean? So what are we going to?
So like,
So
if we put in 21 for degree of freedom in the applet,
okay,
then we put in, what are we solving for? 95%, 0.95 confidence level.
okay, and we only want the center highlighted. Right?
I believe so. And it looks like that gives us a T score of 2.080.
Okay.
And I know that's how we did it for Z score. And I think it's the same.
So then we would do what at this point? 2.080.
We would use that in the equation for margin of error.
So
And the of error equals 2.080 times what y'all just did, D bar over.
okay, so it should be. It should so that the margin of error equation is probably T times S sub D over the square root of N. So that would make it 2.080 times 15.003 over, it's just the 15.003 is over the square root of 9.
Or 3.
Yeah, or exactly. Go back.
Okay.
See what it gives us.
I got 10.402.
Yeah. I think we have the wrong equation because I really think it's the standard deviation or Mean of the differences plus or minus.
The margin of error.
Yeah. I think it's the mean of the differences plus the margin of error gives you the upper confidence level, and the mean of the differences minus the confidence interval gives you, minus the standard margin of error gives you the lower confidence interval.
So what you were doing earlier was just taking the confidence intervals from the paired sample t-tests
Yes.
sheet and using, okay, I kind of get what I understand a little better now. I say let's put.
Should we just put the 6.652 in and then see if it's right or wrong?
Yeah, that's what I was thinking. I just need to work it out real quick.
Yeah, and then if somebody finds the correct formula for the margin of error, please share.
What's the number again?
6.652. Because when I took the top confidence interval, the 18.607, and I subtracted the mean of the differences, 11.955, it gave me the 6.652. And then when I took the lower confidence level, and I took the mean of the differences and I subtracted the lower confidence level, again, it gave me 6.652. So I'm hoping that that's just a backwards way of finding the margin of error, but we'll see.
Okay.
We shall see.
And then it says for 18, input the lower bound. It gives us 5.303 on the page.
Yeah.
Input the upper bound, 18.607.
All right.
Okay, so do we want to just
Give it a
submit
shot.
those?
Yeah, let's see what we get. Hopefully better than an F.
Oh, for the love of Pete, yes.
Yeah. I say, all right, let's see.
Got an 85, or at least I did.
Yeah, me too.
Okay, so we got 17 wrong.
Got
Excuse me,
16.
16 wrong. 15 wrong. Is it one more wrong or two more wrong?
But we got 17 right.
We did. 4 wrong.
Huh. I wonder what's wrong with, I don't know, maybe it depends on the problem. 15? Because with the problem that we tested it on, that D was true, but maybe for every problem it's different.
So maybe not enough information, depends on the problem.
Yeah, that's what I'm thinking.
So, and Laura, can you tell me how did you get the answer for 17? So I can write it down.
We're gonna have to find the
right formula.
the right formula.
Yep.
But basically,
But what do you do?
so in the thing in the middle that says differences, and you've got N, and then you've got mean. So on the quantitative inference procedures.
Yeah.
Yeah. Okay. So differences move over. So the mean of the differences is 11.955. So that 11.955 plus the margin of error gives you, go down to the bottom right corner, the top confidence interval. Again, go back to the mean of the differences, 11.955 minus the margin of error gives you the bottom confidence interval, that 5.303. So I just worked backwards. So 11.955 minus 5.303, the lower confidence level, gave me a margin of error of 6.652.
Okay.
The upper confidence level, 18.607 minus the mean of the differences, 11.955, gave me a margin of error of 6.652.
Okay. Okay, sounds good. Thank you.
Back when we were doing the z-score, the x bar minus the margin of error gave you the lower it was a simplified version of the confidence intervals. So instead of writing out the whole formula, x bar minus margin of error was the lower confidence level, x bar plus the margin of error was the upper confidence level. I kind of did the same thing because the d bar is the mean of the differences. So d bar plus the margin of error would be the upper confidence interval. D bar minus the margin of error would be the lower confidence interval. If that makes sense.
Yeah,
it does.
it's like solving for a different value. It's like algebra.
Yeah. So the whole
No, I think it's genius.
yeah. I'm going to put some of the formulas together that I found, and I will email you what I've got. If you guys will do the same thing, all of the formulas that you've got so far for, 11 and 12, and let's see if we can figure out what we're missing.
Okay, sounds good.
Sure.
All right.
All right, y'all. Well, better than I thought. Better than I thought we'd do.
So we meet Thursday? Thursday at 3?
I will do my best to be ready Thursday at 3. We don't have
me
to
too.
offer anything, so that's fine. Yeah, so please, gather all your formulas and then email me whatever you've got, and then I'll gather all my formulas and I'll email you what I've got, and maybe we can figure out what we're missing.
Sounds good. Yeah, because we shouldn't have to guess at stuff like that.
No.
It's good that you figured out how to get the margin of error, though. I would.
Okay.
Awesome.
Good. Thank you, guys.
But
See ya.
thank you.
No problem.
Have fun with Jimmy John's.
We will. Dinner. Yeah, it's almost 6:30, so I'm sure my children are starving at this point. I'll hit stop broadcast. I will attach this to the, since I recorded, I'll attach this to the group meeting thing. Yeah, I don't think I'm going to mess with this. Okay, thanks, guys.
We're good. Thanks. Have
See
a
you
good night.
Thursday. Or no,
See you
Wednesday. Wednesday.
Anetic said Thursday.
Thursday. Okay, so then we
Yeah.
need to let
Edward.
yeah, Edward know we're doing it
I'll
Thursday.
do that.
I just want to confirm. Thanks.
No problem. Have a good night.
You too. Bye.